ARUP were engaged by the Infrastructure Sustainability Council of Australia to develop the draft Ecology Category for version 2.0 of the Infrastructure Sustainability Rating Scheme, or IS version 2.0. My name is Matt Davis, and I'm an Associate Ecologist in the ARUP Australasian region and the Project Manager for the development of the draft Ecology Category chapter for IS version 2.0. The ARUP team that prepared the draft chapter included Cheney Wheeler, terrestrial ecologist and lead author, with support from Jodie Finson, a sustainability specialist with practical experience in IS ratings, Andrea McPherson, an aquatic and marine ecologist based in the ARUP Brisbane office, and Lillian O'Mahony, the Queensland Environment Team Lead at ARUP. Valuable peer review comments were also obtained from Dr. David Deek in Australia and Dr. Ian Boothroyd in New Zealand during the development of the draft category chapter. This presentation is intended to provide you with a very brief introduction to the draft ecology category for IS version 2.0, including the steps involved in its development. The development of the ecology category for IS 2.0 involved the completion of a number of tasks. The first step we undertook was to conduct a benchmarking study. This study was used to determine the business as usual and leading practices within the industry in ecological impact assessment and risk management, particularly associated with infrastructure projects. Guidance documentation from Australia and New Zealand was reviewed, including any relevant policy documents, technical guidelines, and some peer-reviewed literature. The approaches employed across the various jurisdictions were compared and contrasted, revealing considerable variation between the states and territories of Australia and New Zealand. Some common baselines and principles for best practical ecological impact assessment were also identified, and these were used to inform the development of the draft ecology category chapter for IS version 2.0. From the guidance material reviewed during the benchmarking study, some best practice principles that were common across all geographies and jurisdictions included the need to gain ecological advice early within project planning to allow for ecological impacts to be avoided where possible, addressing knowledge gaps through targeted ecological research, including scientifically rigorous and robust field survey methods and analyses, adopting the mitigation hierarchy to maintain or preferably enhance ecological value through measures to avoid, minimize, restore, and then offset any ecological impacts. Limiting the use of ecological offsets to compensate for ecological impacts and to claim no net loss or net gain outcomes. And implementing rigorous ecological monitoring programs to monitor success and to guide adaptive management. All of these best practice principles were incorporated to the draft ecology category chapter for IS version 2.0. The next step was to carry out a range of industry interviews with practitioners, mainly in the ecological field. This was used to gauge an understanding of the strengths and weaknesses of current industry approaches. 10 Australian and 5 New Zealand ecologists were interviewed, including specialists across a range of terrestrial and aquatic environments, each with considerable experience in the assessment and management of ecological impacts for infrastructure projects. The feedback obtained during this process provided fundamental direction for the establishment of realistic approaches and requirements to be incorporated into the credit for the draft ecology category chapter for IS version 2.0. A primary outcome of these interviews was the identification of a number of shortcomings associated with the current business-as-usual approach to ecological impact assessment and mitigation associated with infrastructure projects. Some common industry shortfalls associated with ecological impact assessment of infrastructure projects that were identified during the interviews were a failure to engage an ecologist or incorporate measures to avoid ecological impacts early in the project planning. One of the key themes that came out of the interviews was that ecological specialists were engaged too late in the planning process, often towards the detailed design or construction phase, whereas early identification of ecological impacts during project planning or due diligence phases, ecological impacts can be identified and realistic measures to avoid these implemented early in the project planning phase. There is an inability to adequately quantify ecological outcomes using the change in land use calculator that has been applied in the previous or current version of the IS rating scheme. There were some comments that this tool was overly simplistic and did not cover the adequate range of ecological impacts, including impacts on features and ecosystem processes. Across the sector, there was an identification of a lack of suitable tools and scientific guidance to assist in deciding when appropriate mitigation measures are implemented. It was identified that management of processes and mitigation measures is usually not carried out unless it's required under a permit or another legislative or policy requirement. Ecological monitoring is very rarely done well and does not often incorporate the use of adequate baseline data. Where possible, we've incorporated the comments from the industry interviews, pulling out the key themes in the development of the draft chapter for IS version 2.0. Drawing upon the structure of the draft ecology category that was initially proposed by the ISCA Ecology Advisory Group, as well as the results of the benchmarking study and industry feedback received during interviews, we compiled the draft ecology chapter. 2 credits are proposed, and together these make up the draft ecology category chapter for IS version 2.0. Eco 1, titled Ecological Assessment and Risk Management, focuses on the implementation of actions to identify and manage ecological impacts and ensuring that ecological values of a site or infrastructure facility are maintained or enhanced. Opportunities to influence net ecological gains, such as through the restoration of habitats or improving ecosystem function, is also encouraged as part of the credit. This credit is proposed to be applicable to all phases of the rating scheme, including planning, design, as-built, and operations rating. Broadly, Eco 1 requires that an ecological impact assessment is undertaken by a suitably qualified ecologist, and any recommendations necessary to maintain or enhance ecological value are implemented during the various phases of the project. The intent of this credit is to reward infrastructure development and operation that results in a no net loss or net gain to ecological value. The ecological impact assessment must incorporate the use of quantifiable metrics to allow for outcomes to be measured and must be peer-reviewed by a suitably qualified ecologist. Guidance is provided on suitable metrics to demonstrate no net loss or net gain outcomes. However, the responsibility to define a suitable metric will sit with the project ecologist, which needs to be demonstrated as part of the IS submission. Another key element of this category is how offsets are addressed. Biodiversity offsets are allowed to be used when claiming a level 2 credit, but to achieve a level 3 credit, offsets cannot be used. The intent of this approach is to guide proponents towards not applying offsets to get a net gain or a net benefit to the project without needing to apply offsets. In other words, it will reward projects that can maintain or enhance ecological value within their site and not rely on biodiversity offsets to meet that gain. The second credit, Eco 2, named Ecological Monitoring, recognises the importance of ecological monitoring in realising the gains delivered by the project. This credit focuses on the development and implementation of effective monitoring programs that guide the collection, analysis, management, and reporting of ecological data and findings, including baseline measurements and post-development or operation comparisons. The aim of this credit is to close the important feedback loop in the adaptive management process by ensuring that rigorous ecological monitoring data is fed back into the management of for the whole life cycle of the infrastructure asset. The credit is proposed to apply to design, as-built and operation phase ratings. It does not apply to the planning phase rating, as the collection of baseline data for a planning phase assessment is covered in Eco 1. Based on industry feedback and advice from the ISCA Ecology Advisory Group, the IS version 2.0 Ecology Category no longer uses the change in land use calculator to define a net gain of ecological habitat, nor does it define sensitive ecological habitats. Accepted industry methods, such as those outlined in the New Zealand Ecological Assessment Guidelines, or relevant policy documents, such as Significant Residual Impact Guidelines, are instead prescribed, with the responsibility lying with the project ecologist to determine most suitable approaches. The ecology category is now ready for industry review. Any feedback received from industry will be used to update the category prior to its release as part of IS version 2.0. Thanks a lot for listening, and we look forward to any feedback on the draft ecology category chapter.